Hello and welcome back to another video provided by SVSU's Online Tutoring. My name is Joel and today we will be continuing on with Chapter 7, Section 7.3, Adding and Subtracting Radical Expressions. And the topic this time will be applications. So with this topic, I'm going to split it up into two different parts, and the reason for that is because there are many different types of applications for adding and subtracting. And one deals with triangles, and the other deals with cost analysis. Okay, so there's graphical bits and everything that we learned previously in back in 7.1. Okay, with radical functions. So we'll start with the simpler application, in my opinion. And that's dealing with adding and subtracting radical expressions for triangles, okay? So if I have this right triangle, and that has some bizarre side links, so like something like 6 square root x 3 square root x, and then 12 square root x, okay? How would I go about finding the perimeter for this? Well, we just have to remember what the equation is for perimeter, right? And that's just the sum of all the side lengths. So P, which stands for perimeter, is equal to A plus B plus C, okay? And you may recognize these three variables back from our Pythagorean theorem. So A is this guy, and then B is this guy, and then our C is this guy right here, this 12 square root x. So all I have to do is just plug in all of my variables, right? So A is equal to square root x, and B is 3 square root x, and then C is equal to 12, whoops, let me put that addition sign there, is equal to 12 square root x, okay? Well, that looks like an A. Let me fix that. 12 square root x, okay? And since there's nothing funky going on here, so I can just add these up as written. So 6 square root x plus 3 square root of x, that's 9 square root of x. So, and then plus 12 square root x, that's 21 square root x. So that would be my answer right there, okay? 12 square root x. Well, let's look at an example where both the number and radical are, or both the number and variable are underneath the radical. So again, I have my triangle, my right triangle, and then the hypotenuse this time will be 15, the square root of 15x, okay? Square root of 15x. And I have, let's say, we'll just put the square root x here, doesn't really matter. And then I have 2 square root x right here, okay? And I want to find out what the perimeter is. So again, I would write P is equal to A plus B plus C. And then I just substitute all my values in. So A is the square root of x, plus B, which is 2 square root x, and then C, which is the square root of 15x, okay? And what I'm going to do is that I'm going to factor out the square root x from these two terms, okay? So I would have 1 plus 2 multiplied by the square root x, okay? And then it's still plus 15 square root x. So I would first add these two together, and then distribute my square root x back in. So 1 plus 2 is 3, and then times the square root x is 3 square root x. Plus my square root of 15x. And that would be my final answer. And the reason for that is that, well, I can't factor out anything from this radical. The factor tree for 15 is just 15, 1, and then 3 and 5, which are both prime numbers, so nothing comes out from there. Okay, that should do it for this part of the topic. We will begin with the next half, starting with functions for radical expressions. Okay? See you next time.